Hi, my name is Yvette Solis. I am in Dr. Chan's biology course, and today I'm going to be talking about cellular respiration. In the cellular respiration process, there are the steps glycolysis, the Krebs cycle, and the electron transport system. The reason I chose this is because I have a lot of trouble with this category, and I'm going to practice saying it here. I'm going to look at my notes. So, okay, let's do this. So there's 10 steps to glycolysis, and glycolysis occurs in the cytoplasm, and it is an anaerobic process, so there's no oxygen involved. In the step 1, there are 2 ATPs that are invested in the glucose. The glucose becomes a 6-phosphate, and the ATP transforms into ADP. Step 2, glucose 6-phosphate transforms into fructose 6-phosphate, and then step 3, fructose 6-phosphate is given ATP. This transforms into the fructose 1,6-biphosphate, and ATP is once again transformed into ADP. Step 4/5, there's 2 steps in this one because fructose 1,6-biphosphate splits into 2 carbon to 3 carbon sugars, so it can go 2 ways. It can go to the dihydroxyacetone phosphate or the 3-GP. But only 3-GP can go to the next step of glycolysis, so it'll mainly be 3-GP. Split into 2 3-carbon molecules. This is where it goes into 2 3-carbon molecules, so the next steps are going to be pretty much doubled. Step 6. 2 reactions are happening at once. The 3-GP is transforming into the 1,3-biphosphoglycerate, and NAD plus becomes NADH. Step 7, the 1,3-biphosphoglycerate donates 1 phosphate group to ADP, creating ATP, therefore turning into 3-phosphoglycerate. Step 8, 3-phosphoglycerate converts into 2-phosphoglycerate. Step 9, 2-phosphoglycerate loses its water, therefore becoming phosphonopyruvirate, PEP, and PEP is really unstable, so that goes on to step number 10, where PEP donates phosphate groups to ADP, becoming ATP. This is the final product, and losing its phosphate makes it transform into pyruvate. The result is actually 4 ATP, but because there was 2 ATP given and we only got 2 ATP back, 2 NADH and 2 pyruvate. And this is the entire process. Then on to the Krebs cycle. In the Krebs cycle, we finished here with the pyruvate. This is gonna go on to oxaloacetate. In oxaloacetate, there are the 4 carbons. And I put all of the steps, but I'm just going to go ahead and read it off my notes. The oxaloacetate has 4 carbons, and with the pyruvate, you get the acetyl-CoA. So this is actually a good one. In first step of Krebs cycle, acetyl-CoA combines with oxaloacetate in the presence of condensing the enzyme citrate synthesis. CoA is released out. The product of condensation is citrate, which is a tricarboxyl 6-carbon compound. From here, it's a lot easier. From here, it's a 6-carbon molecule, and with NAD plus converting to NADH, you lose the carbon dioxide molecule, producing a 5-carbon molecule, which is the next one. And then it happens again, where the carbon dioxide is lost and NAD plus becomes NADH plus. Just NADH. And the next one is where we get ATP. It's cut off here, but this is where you get the ATP. Once again, you lose. You don't lose the carbon dioxide, but you have to gain it with FADH. So we're not using NADH anymore, we're using FADH2. This helps us get to oxaloacetate, which is important because it's also in photosynthesis. The difference between NADH and FADH is that NADH is more powerful, while FADH just captures some energy, just enough for it to go on. The next step of the cellular respiration process is the electron transport system. Here, let's see. This is located in the inner membrane. So here's the inner membrane. And these here are, they're the proton carriers. Yeah. Transport electron carriers. Okay. So NADH is carrying the electrons to NAD transfers hydrogen to the electron transports, and hydrogen is produced of protons and electrons. The electron transports electrons and carries them to the carrier protons. This goes from the NADH to electron acceptor. Oxygen. From there, electrons carried through shuttle, protons converted. Oh, and the protons are converted outside. So here go the electrons, and the protons go this way. Once they reach the ATP synthase, the enzyme ATP synthase creates ATP out of all these electrons using the proton force. Once ATP is released, the protons are once again met here, producing ATP. And this is all the steps of that. And all in total, we should be getting 30 to 32 ATP. I got off the notes that it was 36 ATP, but it's actually 30 to 32. And that is all of the cellular respiration cycle. Thank you.